All right, so hello. Everybody can hear me? Yeah. Everybody well rested, slept well, showered after Busenby last night? Good, so am I. So, welcome. I'll introduce myself first. My name is Martti Nurmikari. And when I'm not doing demos, I'm a game programmer at Bugbear Entertainment. And actually, there are some people tonight coming to talk about our game, so if you're interested in that, go check it out. But this presentation will not be about games, it will be about demos. A lot of what I will be discussing will be applicable to games as well, so if you're interested in game development, I hope you can pick up some tips. So, why are we here? I'm hoping to give you some kind of a brief overview on what happens in a demo. For the past 3 years, I've had a presentation here called Introduction to Demo Programming. That one was a kind of really basic, simple stuff, how to get actually started, how to get your window running, so forth. This one will be a bit more detail and less of the how to get started. I'm going to give you some implementation details on some specific stuff. I'm going to give you, hopefully, ideas on how to build your own demo framework. And of course, I'm hoping to give you tips on like how to avoid silly mistakes that I've made, for example, in the past. So, and of course, if you feel that like I'm talking nonsense, or you know a better way of doing something, that's fine. Demo programming is kind of hacking in a sense that people do things their own way, and if you feel like your way is better than mine, go for it. So, the contents of the presentation. First, I'm going to go a bit through the basics on like how demo engine would work. Then we're going to talk about resource management, how to load your textures and shaders and whatever so that they're comfortable to use. Then we're going to build a timing loop, which is really simple but also really essential on how to like build a properly working framework. Then we're going to spend a bit of time on synchronization. And I think synchronization is basically the only really demo-specific thing in programming. Everything else is you can use somewhere else, but like synchronizing between visuals and audio is something that's really specific to demos. Then I'm going to give you some tips, quick tips, hints, pointers, and then there will be time for questions. So, the basics of demo engines. There are two kinds of engines. There's this editor-based, where you build a tool that will allow you to edit graphics and timelines and so forth. And then there's this old-school way, which is more like you write effects and demo stuff directly without using much tools. Now, the editor-based is kind of modern way to do things. I'm not gonna discuss it here because it's quite different and it's a bit more advanced. But if you come to talk to me later, I can give you some pointers if you're interested in that. Personally, I don't use editors or anything. I hard code everything. That's my way of doing demos. So, what is actually needed in a demo? And how would you define a demo? A demo is non-interactive, usually non-interactive presentation that has visuals and audio. So, basically, what you need is the effects and the visuals. Resources that like graphics, shaders, meshes, splines, whatever. You need synchronization to make it look good, and then you need probably some parameters so you can tweak it in real time. And the basic point of a demo engine is that time goes in and demo comes out. This means that you have the interfacing to your operating system, and then you have your demo. And the demo shouldn't depend all that much on the operating system, so it should be like abstracted. I spent quite a few slides on this last year, so if you're interested in the details, go check that out. It should be available online. And some assumptions that I'm going to make for this presentation is that we're going to be talking about doing a simple demo with hard-coded effects. So your basic first demo, or well, I guess in my case, like 50th or something, but still very basic. We are not going to be talking about editors, as I said, no user interfaces or anything like that. And I really feel that even if you really want to do a cool demo tool that you can make 64K intros out of, it's better not to do a simple demo first, so you can actually get a hands-on experience on how to do demos and what do you actually need. That's a very good way of avoiding mistakes, to do something really simple first. And it's also really educational. And I'm also going to assume that you have your window handling your music system set up and so forth. So you have like your favorite MP3 playing in the background and something rotating or flying on the screen. Yeah. So the first thing I'm going to be talking about is timeline management. Like what gets drawn when and how to control it. Now there are two, like in this kind of hard-coded, old-school kind of coded demo, there are basically two ways to do this. There's either a huge hand-coded, hard-coded mess of stuff, which is maybe not that good an idea. I've done it a few times. Like the last demo I released had, I think the demo loop was like 4,000 lines long, and it was all in one single file. It was absolutely a mess to get anything done, but it was also a really fun exercise to doing stuff. The other way, which I definitely recommend, is like you have a list of drawables inherited from a base class, and then during a frame, you go through all of them, decide which one should be drawn now, and sort them, and then draw. So with this kind of approach with drawables, you have in your base class you have init, update, and draw. Update and draw are only called when the effect is active. And to know which one is active, you have start time and end time. And basically, in my engine, these are milliseconds, so I can define that the effect starts at 1 minute and ends at 1 minute and 30 seconds. And then all the drawables have a priority. So it's important to control which one gets updated and drawn on top of which one, so you can basically sort them in the correct order. Now, how to define a drawable, like which is a drawable and which is not, that's a very good question, and it's up to you if you're going to approach the demo doing this way. I usually have, if I have distinct scenes in a demo, I usually have them as a single scene class. My drawable is called a scene. And if like a scene has a bunch of different elements, then the scene handles those elements separately. Usually the elements look quite a lot like this, but I like to keep the top level abstraction really simple. So effect timing. So how do you actually like decide which effect, specify which effect will be drawn when? There are basically two ways approach to this. One is the raw timer data, milliseconds. This is the simple way. This is the way I do stuff. But there's also another way, which is based on musical data. So you measure, instead of measuring time as time, you measure them as music. So you have, let's say, 120 beats per minute in your song, and then you can calculate like every 16th beat you move something, or every triplet you do stuff, and like that. Lots of people recommend doing this. It's good for some different kind of demos. Like for example, if your song is really fast, this can be used to get a really accurate synchronization. And of course, you can combine both of these in your engine, so you can use either one. Okay, so the resource management. This is the thing in a demo engine that is easy to get really wrong. And it can make your life really painful. So as it's highlighted on the red, do not load and handle resources manually. Like what this would mean is basically, let's assume that we have a bunch of textures that we want to load. So it could look like this. So you have, let's say, there are eight texture objects created here. And actually, I think there are five bugs that I put in this code. And you can't really spot them out. Of course, it's really small. You can't really see it either. But this is, as you can see, this is really not the way to do resource handling if you have more than like one resource. So as I said, it's difficult to keep track of them because there are so many. It's really difficult to share them between demo parts. So if you have like a demo logo that's used in one drawable, and then you have another drawable where we want to also use the demo logo, you have to somehow give the texture, share the texture between these two. And that with that kind of management, it will be really, really, really horrible. It's also slow to do. It will take up all your time to like handle like where did I load that texture that I want to use here. If you need to release and allocate resources on the fly, it's really hard. You will get memory leaks, and you can't really keep up track of which is loaded where, and you will end up with problems. So the best way to do resource management in a simple demo system is the manager pattern. Now, the idea of the manager is that you have one single object that will handle everything. So texture manager, shader manager, sync manager, and so on. And everything that happens to a resource goes through the manager. It's great for debugging and tuning, so you can put all kinds of debugging code in the manager. You also don't need to duplicate any code, since all the texture handling happens to the texture manager. It means that you only have the texture stuff once. You can build all kinds of nice abstractions inside the manager. I think that managers in a simple demo engine should be implemented as singletons. So what a singleton means is that you have only one instance of the class active. And they are great, easy to implement using an associative array. So with C++, that would be std map, for example. So an associative array is an array where you can, for example, map strings to texture objects. So in practice, what a manager looks like would be something like this. So instead of doing manually loading each texture, you would tell your texture manager to init from a directory. It would load everything there, and then in your effect code, you would basically, with a single line, you could bind a texture. So what this inst there does is that it gets the instance from the singleton, and it binds the texture by the name and the texture unit. This is actually quite straightforward copy paste from my demo. And as you can see, there's just like one line of code to do all the nasty resource handling once your manager is done. So that's really something awesome. All right, now the second thing, timing loop. Now this is really simple to do in practice, but it's also really simple to get wrong. So what do we want from a timing loop? We want the demo to run at the same speed on all computers. Now, of course, you can like smile and laugh at it, but people do things that will break this, and it's sometimes really embarrassing to watch. We want the demo to keep in time with the music, which is important for synchronization, and we want to make it simple. And in the following examples, we have one moving object, but the object moving code basically represents your entire demo logic update thing. So let's build a timing loop. Now, this is the stupid timing loop. We just, whenever the engine update frame is called, we just move by a constant. This is not timing. This is just updating. But people do this, especially in some crack throws. You sometimes see that they assume that the display or the display drivers somehow limit the frame sync to like 60 frames per second. You can't do that on a PC. This is a very valid approach on Amiga or C64, where you have a fixed platform with everything running at the same speed, but you can't do this on PC. So we're going to improve this by doing another kind of update loop. So in this update loop, we measure the difference between the last frame and the current frame. So, for example, if your demo is running at 100 frames per second, then the DT, delta time here, would be like 10 milliseconds. And then each update, you would move it by an amount that is correlated with the update time. So if your frame takes a long time, then the object will move a lot, and if it takes just a short amount of time, then it will move fast, or but the delta will be small. But there are some really nasty problems with this kind of approach. The worst one being that if you do it like this, then you will need to keep the delta time anywhere. every single time something moves or something happens, you will need to keep track of the delta time, and that will be a burden. It will be both design-wise, it will be unpleasant, and also if you have lots of updates and stuff happening, it will also be slow. Because even if modern computers have gigahertz and gigahertz and quad cores and whatever, it will be still might be a lot of multiplications. So you don't want to do that. Another problem with this delta time approach, as it is here, is that especially if you're dealing with small floating point values, inaccuracies will build up eventually, and for example, in physics simulations, it might be unpredictable how it actually works after a while. So you really want to avoid that as well. So we're going to do a different kind of approach to the delta time thing, which is basically a fixed time step. Now, what a fixed time step means is that you define a time that your frame will take. You will define that your frame will, let's say, take 10 milliseconds, so that would be 100 frames a second physics update, or you can define 20 frames you want to, whatever. And instead of using the delta time directly in your update loop, you will wait until you have accumulated enough time so that you have actually passed the frame length, and you will then do a fixed time step. So all the time steps will be the same length. So you can get rid of the dt in the calculations, and you can go back to using constants again. Now with this kind of approach, there is a fatal flaw, which is you can hit it. I've hit it. My loop used to look like this. And the problem is that if your frame updates suddenly get really slow, let's say you suddenly have 100,000 huge particles on the screen or whatever, and what will happen is that your frame will take a long time. Then you will kind of be backlogged. So you will need to build up more frames, and you will get an exponentially increasing amount of updates, which will quickly turn into basically infinite loop, because your engine can't keep up with the updates. Now, of course, this kind of slowing down shouldn't happen ever. Your code should be done so that it will not happen. But at least with particles, I've had it happen many times, also at work. So for demos, there is a really simple solution to this kind of problem, which is highlighted in red in this code. So you basically just decide that you will not do more than, let's say, 10 iterations of the update loop. This might mean that your demo will not look correct, but at least it will not crash. And this is more just like a fail-safe. Fail-safe for this kind of eventuality. So some few words about implementing timing. By the way, this is the exact timing loop that I'm using in my demo engine. It runs fine. So some words about implementation. On Windows, we have this fantastic thing called timeGetTime, which is a really simple function. It will return you milliseconds. You also have, in Windows, you have high-performance timers, but those actually nowadays, modern computers, they have some unpleasant issues. Like if you have a multi-core machine, it might be inaccurate, and you can't really trust on those. So using timeGetTime is simple enough, and I've been told by the experts that it's actually better nowadays to do demos with that instead of high-resolution timers. Also, if you're doing like a 4K intro or something, it's one function call, so it's really simple. Usually, also your music player, you will have a timer, so you can query the stream position, like where are you in the song. I advise you you shouldn't use that. Like many timer implementations in music libraries, they have issues. Like for example, Fmod, which is a great package that I use. the timer has a flaw that it will only update like 24 times a second. So whatever you do with a fmod timer, you will get 24 frames per second, and that's bad. So roll your own timer. It's really simple. But of course, with your own timer and the audio system timer, you need to somehow to keep them in sync. So it is possible for threading issues and whatever to like make them timers drift apart, which will lead to that your demo will not be in sync, and that will not really be good at all. So what I do in my engine is simply every update I take my own timer time and the timer from the audio. And if they are too much apart, then I will just force the timer time to actually be the audio time. So this will mean that you might get like this small choppy movement for like 1 frame. It doesn't really matter at all, but it will keep your visuals in sync with the music. There's also something that I wouldn't use for demos necessarily, but there is like for games, there is one more improvement that you can do to your timing loop. It's something I call fractional frame update. And like imagine if for example, you're running on a really monster computer and your game or demo runs 300 frames a second. So if your timing loop only updates 60 times a second, that means that you're like for the 5 frames you're showing the same picture. And for demos, I think that's fine, it doesn't matter. But for games, you can do this kind of fractional updates. So instead of like visually showing the latest frame, you can actually calculate that fractional frame. So you interpolate all your data between these 2 frames. So basically, you're lagging 1 frame behind, but you have this smooth movement, and it will update the visuals every single frame. For games, this is pretty good, but it requires a lot more from your rendering pipeline. So with this kind of approach, you need to interpolate the frames. You need to make sure that somehow your engine will handle the fraction correctly and so forth. For demos, I've never seen a really reason for this, but for games, it's awesome, and you really should consider it if you're going to do a game. So that was it for the timing. Now synchronization. I think to make your demo look good, this is the key. It doesn't really matter if your technology is bad and your effects are poor and your music isn't really that great, but if you have really awesome synchronization, that will mean that your demo is interesting to watch. Also, this is something that's very specific to the demos. So you don't really, with a game, you have a player and you shoot a gun. So when the gun goes off, you play a sound. But with a demo, it's the other way around. So when something happens in the music, you need to react to it in the graphics side. Synchronization is usually, it takes a lot of time to do properly. So it's like small tweaking and more small tweaking, even more small tweaking. The way you do synchronizing depends on the demo that you are doing. So if you have, let's say, 15 minutes of ambient noise, it will require a different kind of syncing than, for example, a demo with, let's say, a trance soundtrack. And that's also what makes it fun to do. So now I'm going to show you a few things about methods that I use in my own engine for syncing. Now, of course, this is very, very personal, and there are many ways to do this. There are also many free tools. For example, something called GNU Rocket, which is awesome if you don't want to write your own sync stuff. But I wrote my own because that's why I do demos, to write my own cool stuff. So in my engine, I have something called an event. So an event is basically something like if time is past a certain point, something will happen. It's how it looks in code would be like this. So I have a script file where I have a bunch of stuff, and here I declare an event that's called logo fade in. We decided that the logo will fade in at 1 minute, and it will fade from 0 to 1 in 4 seconds. So in code, again we have this sync manager, which contains all my synchronization stuff, we query an event called logo fade-in, and then for each kind of sync, I have something called get value, which basically, in this example, get value would return 0 at exactly 60 milliseconds, and exactly 60,000 milliseconds, and exactly 64,000 milliseconds, it would return 1. So it would, and it interpolates between those. So it goes from 0 to 1 in 4 seconds in this example. And then I could just like draw a picture with the alpha, and it would fade up nicely. Events are good for stuff like has, for example, some sound happen in the music, or has the music changed somehow, or like inside your effects and scenes, like at half point in the scene, you could like switch colors or something, and the events are used for that kind of stuff. Then I have triggers, which is basically the same thing, except that there's like lots of them. And for example, if you want to make something that flashes every single time you hear a sound in the music and so forth, a trigger would be awesome for that. Here's an example. Again, in my script file, I have I declare a trigger called beat flash. So it will happen at 3.5 and 5.5 and 7.5 seconds. Each of the flashes will last 1 second. And again, I query it from the sync manager, like give me trigger called beat flash and get value. Again, the get value will calculate the value in the like how far we are in one of these triggers. So this is basically just many events rolled into one. I could use, of course, like triggers for everything, and I just have a single trigger for each event, but I kind of helps me mentally to keep them separate. So then we can sync with splines and curves, which basically means that you have a mathematical function that you give a time, and it will give you a value. So, for example, if you want to fade a logo, you could make a curve that will, at 60 seconds, it will be 1 as a 0, and at 64 seconds it will be 1, and you could just like fade it up with the curve. Now, how do you define a curve? There are lots of different kinds of curves. Cat-Mulrom, Bezier curves are good. You can use Hermite splines or whatever. There's lots of different choices. Or you can define your own like functions, like powers and signs and whatever. Now, if you're going to be working with splines or anything like that, you will probably require some kind of editor to actually design them, because you don't want to like type in a bunch of coordinates by hand and then see what they do. That's, especially with Bezier curves, that's horrible. Then you can sync by BPM, so that's beats per minute in the music. So the idea is that you calculate where are you in a song. Let's say the bass drum of your tune hits at every bar, every first and third quarter note, for example. So you can calculate where you are inside the song and use that information. So this would, if you have no idea on how like rhythm and music theory works, this might be a bit tricky to get done right, but it's worth learning. So what this could mean in real life would be something like this. So we have beat in the sync manager. It's declared in again in the script file. I didn't write it here, but let's say we have 120 beats per minute, the song. So we can for the beat synchronization, we can decide that we want everything, like when the measure of bar changes, you will change the camera position. So if you have unch, 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 it will like switch every 4 unch, or every you could have like it flash the screen. And it's with this kind of beat synchronization, it's really easy to do that kind of synchronization, and you don't have to like write 250 trigger lines manually. Yeah, this is something that I use a lot personally, and it's really I really recommend that you build something like this in your engine. Now, and then there's the fourth or fifth, I don't know, way of syncing, which is by using the audio data. So basically, you would get the data from your audio system and sync using that. Now, every single good audio system worth using will give you some form of FFT. So it will give you the frequencies that your song has at that point. For example, you could make the red objects react to bass frequencies, and you could make your blue objects react to treble and so forth. This is 100% exact, so you can't really not react. Like if you get values from your audio system, you really cannot not react to those properly if you just write the code. And if you do it well, it will be really awesome because it will really make your demo alive with the music. Now, there are of course downsides to this kind of approach. For example, the frequencies that are in your music file, they depend completely on the song itself. So this has to be hand-tuned for each demo. And it depends on the mixing and the mastering of the demo tune. I have a really personal example for this. At Assembly 2006, we released a demo called 2 to the 5th. And we had lots of this kind of frequency synchronization on it, and it just tuned really well. And then the musician decided that he's not really happy with the demo tune anyway, and he remastered the demo tune. And we released a final version with a crash bug fix and the new version of the tune, which I admit it did sound better, but it screwed up a lot of our FFT-based synchronization because the frequencies in the final master were different. And that's why there are, for example, some things flash way too much because the bass frequencies are higher. And also with this kind of frequency synchronization, the frequencies in the tune, they usually change really fast. And you probably need to do some kind of signal processing on those, like filter it. For example, if your music system returns you, let's say, an array of, I don't know, 512 floating point values, which would be the spectrum. If you, let's say, decided that this something will flash to the sample number 29, which will be like really low in the bass end, it will flash unpredictably because the frequencies change in the music. So we'll probably need to smooth them out somehow, and or like calculate some kind of rolling averages or whatever. But it's really worth doing. And also, I think this is one of my favorite ways to sync, exactly because it's an art and not a science. So there's no formula recipe how to do this right. You just need to try stuff out and see what works. And that's for me at least, that's really fun. So that's basically how you could start building a demo engine. The essential parts, I think, what I use for demos isn't really much more complicated than this. By the way, all my source codes are for my engine. If you want to see how my engine is built, they are open source. So you can check them out, and you can use them if you want for your own demos. And finally, I want to give you guys some tips on how to, on different kinds of things, and how to make it easy for you to make demos. So number one tip, and this goes for all kinds of programming, keep things to unity, so between 0 and 1, because it's really easy to react to, for example, sync values 0 to 1. If your sync value would go from 0 to 17, it wouldn't really make any sense, and it would be kind of difficult to understand and use. And also with the values in Unity, most operations on numbers in Unity will yield Unity. So for example, if you have a value from 0 to 1, and you can take, for example, sine, you don't get anything really weird out of it. Or if you multiply two numbers in Unity, it will still be in Unity. And that's really awesome, especially for graphics intensive stuff. Also, with your demo engine, you will want some way to real-time modify your parameters without restarting the demo. You can spend a year doing a demo, and if you don't have any way to change your parameters while the demo is running, you will spend a lot of this time do stuff, change, recompile, do stuff, change, recompile, change value, didn't like it, recompile, so on. That's really slow. You can write this down in for example, an XML file. XML is pretty much made for this, or you can write your own format. I have my own. I probably should use XML. And also, related to this, you will probably want play, pause, rewind, reinit functionality, so you can do like start playing a demo, see how your values look like. You don't like it, you pause it, you change the values, then reload it, and so forth. You can do this kind of stuff with a script file without actually doing an editor. Of course, an editor is better, but it's more work, and it might be something that you're not really that interested in coding. Also, nonlinear interpolation is awesome. So, for example, if you move your camera, don't ever move it in straight angles. That will look horrible. So use splines or cosine interpolation or anything like that. It will look much better. And don't be afraid to experiment with crazy stuff, because like when you're doing your effect, it's basically just like playing around with values and see how it looks well. And if you like come up with something really freaky or weird, that's great. Some more tips, like useful math stuff. I've been asked this a lot, like what kind of math do you need to do demos? You don't really need all that much. You need to be an average programmer to actually get it up and running, but you can really get by with really little. Like, I didn't talk about effects here because effects are just graphics programming. It's nothing more than graphics programming. Anything in your favorite books on computer graphics programming will teach you how to do demo effects. You just have to be creative. So you need vectors and matrices, definitely, but maybe like high school stuff should be enough. You need some trigonometry, so sines and cosines. You need to understand how and why those work. If you want to do physics simulations or something like that, you might probably want to do some numerical algorithms. Splines and other polynomial curves are really necessary to make things look good. But really, I think demo programming is not that much about math on PCs. It's more about expression and ideas. And finally, I think that demo coding, even though you do it with technology, it's an art and it's not a science. So be an artist, and like it's a fantastic way to express your own creativity, in code, and that's beautiful. So that's the presentation I had for you guys. I think we have some time, so we can take questions. The slides will be probably up on the assembly website and also on my webpage, elsewhere.st.cx/demo programming. There's also a bunch of demo source codes and so forth there. There's my email address. You're always welcome to send me an email and ask about stuff. I'll help you out. I'll give you source codes or tell you how to do stuff and whatever. And I guess that is what I had for you guys. So if you have any questions, I'll try to do my best to answer. Anyone? Well, you're free to come to talk to me afterwards, or send me an email. So that's it from me, and I hope to see lots of good demos from you next year or this year. Thanks.